This ICP is all about understanding artificial neural networks and types of artificial neural networks and its applications, encoders and convolution neural networks and autoencoders. The main objective of this assignment is to know about convolution neural network models and encoders, and we need to train models using various data sets. We have downloaded the source code. Coming to the part 1, loaded the nested data set and dividing it into 80-20 ratio training testing groups. Nested data set of handwritten digits was used as the basis for this study. Here is the code for this part. Coming to the part 2, we created an encoder with a 784 input size and 64 encoding size. The encoder will decrease the input from 784 to 64 and it will increase again back to 64 to 784. Here is the code for this. And coming to the part 3, we can make a prediction after training the model. We first train the model before making a forecast. We begin by constructing and training the model. Then between the input and reconstruction, we apply the Adam optimizer and mean squared error loss. Here are the results for this. Here are the test images prediction. Here we can see the visualization results. Coming to the part 6, here is the input and here is the output. Here is the encode, here is the decode. Coming to the part 6, for nested dataset which is 28 by 28 and contain a grayscale digit. Here a CNN model will be built. We'll start by converting the image pixel values from 0 to 255 to 0.5 to 0.5. This will make us easy to train our network and it leads to better results. Here is the code for this. Coming to the part 7, it completes the models compilation, which represents the linear stack of layers of the functional model class. Because our CNN will be a linear stack of layers and we will use the simple sequential model. Here is the code for this, and here we can see the model for 30 epochs. Here we can see the prediction using the model. From the next topic onwards, my partner will continue.
Like as a part of ICP, we have taken CIFAR 10 dataset as an input. This is a typical dataset used in computer vision and deep learning. Like it contains a small photo categorized issue. Even though the dataset is effectively solved, it may be used to learn and practice how to build and train the models using convolution neural networks from scratch. As a part of this, initially we imported the dataset which contains 5,000 samples for the training and 10,000 samples for the test. Like we use 80-20 ratio training and test split. You can see it here. And now coming to the part 2, it has an encoder input size of the 3072 and the encoding and 128 is encoding size. The auto encoder string the input from 3072 to 128 and then expand it to 128 to from 128 to 3078. You can see it here. And the third part is like training the models. Initially we train the models before the forecast, and in input and reconstruction we apply the Adam optimizer and mean square error loss. The test is now encoded and decoded to see how the model performs. You can see it here. So we have taken 50 epochs and batch size is 256. You can see the test image prediction here, and you can see the visualization results here. And coming to the part 6, the CNN model we built for the dataset is like contains 30 by 30 pixels and has a color scheme, RGB color scheme. We'll start by converting the images pixels from 0 to 25 to 0.5 minus 0.5, like to normalize this. Like this for normalization. This will make it easy to train our network, leads to better results because Keras requires a three-dimensional data set. We also restructure each image from 32 3 denotes the color schema. You can see it here. And the next part is compiling the model. So Kira model is either built using the sequential class, which represents a linear stack of layers, or the functional model class, which is more customizable. So we'll be using the simple sequential model, since our CNN model is a linear stack of layers. You can see it here. All like we have used different sequential layers. You can see the code here, and we have taken so the coming to the parameters, hyperparameter accuracy, I will be explaining. The accuracy, you can see the accuracy of the model is 76.5 here, and the prediction for the first 25, you can see it here, all are matching. So that overall accuracy is 76.5, but the first 25 is 100% matching. And about the data set, as I explained before, it is a set of photographs used to train machine learning models. It's one of the most used data sets. So like as I said, it contains 6,000 entries, like color 32 by 32 color images. It is divided into 10 categories: airplane, vehicles, birds, cats, deers, dogs. These are the various categories. And coming to the hyperparameters, we use num filters 8 and filter size is 3, pool size is 2. The gradient optimizer used is Atom, and the entropy categorical cross entropy is more than 2 classes, and above are 20. And we have also observed that the C4 dataset is differ from the NINST dataset. Is that like photos of various objects has a written and NINST dataset has handwritten digits. The reshape size from for MINTS is 28 and 1, since it is a grayscale image, while the reshape size of C410 is 32 and 3, because it is a RGB color scheme. So during the construction of the sequential model, a few changes were made to the CNN model in the layers. The model layers are subject to maximum pooling. When the model predicts images from the test dataset, the results match the ground truth, so which is the dataset's actual images. The model can categorize the photos. And coming to on the conclusion note, in this ICP we learned about the autoencoder and CNN models and how to train them using CNN model and TensorFlow, as well as how to run the CNN model using TensorFlow and Keras libraries, and how to install various Python libraries. And the main challenging part is understanding and analyzing the MINST handwritten digits, and training for datasets is challenging. Thank you.